Audio Jungle.
Java is brought into existence because of the drawbacks of C as a procedural language. And when we are working with C, we understand that C as a programming language was such a powerful language where we could write not only the basic programs in terms of just writing a simple program to to calculate the report of an employee, but also we could also write a complex program where I can generate some game in C. So when C was such a powerful language where we say there are several drawbacks of C that helps us to think why we should go into Java as a programming language. So when I talk about the features of C programming language, I can say it's a structured language. Okay, it's a structured programming language. That means structured or modular programming language. And with this structured or modular programming language, I can divide a big program into modules. And it is also a high-level language, okay? And with this high-level language, I'm able to write programs in English and they are executed on the compiler. But C allows me to write not only a basic program, but it allows me to also go from a basic to a complex program. Okay. Now, still, when we are writing C programs, which is basically written for the operating system, there are several drawbacks what I can think about C, which helps me to move into Java programming language. Let us quickly discuss about few of the drawbacks, and we can think what is the advantage of Java or other object-oriented programming language. When I talk about C programming language, we know that when I write such a program, I have blocks, okay, or modules in which I write the program. So in my file that I have, so I have a file called, say, calculate.c. This is my file name in C, and this file is divided into several modules. So in this I have one module called main. I have a module, say, because it's a calculator I want to add. I have a module called subtract. I have a module called multiply, and I have a module called divide. Okay. So this is how I divide a program as a modular program to go with. Now C, the good thing is it divides into modules, but each of these modules, okay, is separate from one another. So there is something called a calling module and a called module. So there is nothing like, as an integration anywhere to go with. Each of them is a block, one becomes a calling and the called module. Now if I understand this structure, I can understand that in C, you have for all variables, you have something called forward declaration. That means I have to declare the variables and only then use it. Okay. The third drawback in C that I talk about is, because of these variables, the forward declaration, all the variables are declared in the main method. Okay. So I have variables declared in main method. I have variable declared in main methods. So what happens when I have a method, say from main is calling a method, say add. Okay. Internally, add may also call a method called multiply. So what is happening here is, if I think in main I have these two variables, which are A and B. Okay, I have say sum, I have A and I have B. Then these three variables which are declared in main, all these three variables have to be assigned before they are used, declared and assigned before they are used. And it may happen that both these variables are being used by this method add as well as this method multiply. So in this particular scenario, if there are two variables that are declared globally, okay, so I'll have global declarations, and when they are declared globally inside main, there is a chance always that variables gives us a problem of inconsistent data. So inconsistency is a major problem. Inconsistency of data is a major problem when we go with C. There is no protection of data. And C being a procedure language, the thing here is when C is a procedural language, with C you think only about procedures and not about the data. Okay? When I think in procedures, I only think about what should I do. Okay? What to do. I will always think in terms of steps. The major concern what we are talking here is we are not bothered. We are not bothered about the consistency of data. Okay, I'm not at all bothered about the consistency of the data. This is one such major drawback of C, what I say here. Okay, so one of them is a global declaration. The other is we are not bothered about the consistency of the data. If I look a few other problems when I go about, suppose I have this method add. And for this method add, suppose I write the signature like something like int add, and I'll say int A, comma int B. Because my program is simulating to be a calculator, if I think about real-time scenarios, I may have to write a method which also takes different parameters. So suppose I say int add, suppose I want to do arithmetic with double A and double B. The problem with C here is C will never allow you to write two methods with the same name. It will never. So it forces you that either you should separate this method with, say, suppose I write a method add int, or I write a method called add double. Okay. Now in this scenario, if you actually look, if I'm simulating a calculator, the major thing that is happening is when I'm talking about such a scenario here, so if I have another method that I'm writing, say suppose int add, okay, add, suppose I want to add a float and a double as a data type. So then I'll have to write float A and double B. So C will never allow me to write two methods with the same name. So what is happening when I'm writing a small program, the program is easily manageable. But as the complexity of the program increases, maybe I'm writing so many methods and each method manipulates these variables A and B. Okay? Each method may be manipulating these variables A and B. At one time, the data will not be in a consistent state at all. So this is one problem, one drawback in C, where I have no reusability of methods. Reusability in the sense, if I talk about, I can call one method from the other method. But to be more precise here, C will never allow me to write, so I'll say cannot write two methods with the same functionality okay, with the same name. So what I'm looking at is something like this. if I think about a real calculator, I'm also looking something like this, that there should be some feature that should have been provided, because I know it is going to be addition of A and B always, and storing the variable in a result, say sum. I would always want that when I'm providing, the functionality is addition of two numbers. So when I say A plus B, and A plus B, this functionality will never give me the same name. So this is one drawback, what I see of C. So, and if one method makes a call to another method, then both of them operating on A and B again, the data will surely be in an inconsistent state, right? The sixth drawback, if I think about C, I'll say no, C does not provide any support for exception handling. Okay. In the sense, if I think about, you can observe here that whenever I write a program in any programming language, there are three things. One, I have to accept input. Two, I have to do some processing. Three, I have to generate some output. Okay, I have to generate some output. So, show output. Now, what happens here is, assume I'm accepting two numbers from the user, say A and B. So I'll say enter two numbers. Now I want the user to enter two values for A and B. First of all, there is no guarantee that the user is going to enter two numbers. There is no guarantee, even if he enters two numbers, I may want it to enter two numbers which are, say suppose I want two numbers greater than 10 only, or greater than 0. He might enter a negative number. The same way, when I'm doing processing, there might be every chance that I want to write some decision logic which says, if the sum is greater than 100, then I do it, else I want to display something. So you will see that throughout the C program, I can never ensure that every time my logic is going to be correct. I will always have to write some cases where I have to display some error. So what happens is, all the logic and all the error handling code is always written in something called as an if block. That's a basic structure what I have. So I'll have to write the condition, and I'll say if condition is true, then you do this. So then I say write the logic, programming logic. Else I have to say, I have to write error handling logic. Write error handling logic. So if you observe here, when I'm writing such a structure, my program will not only have that code to process the data, but my program will also have the code for the error handling. So at one time, such a logic or such a piece of code will give me something called a spaghetti code. Spaghetti code. When I have this spaghetti code, the problem here is, when I make a call or a nested call, along with clubbed with a feature what C provides, say go to, at one time I will never be able to identify the cause of the error. It's very difficult to debug, and that is very difficult to trace, because the entire structure of the program is mix of if else, if else, if else, if else. And as the size of the program increases, it will be very, very, very difficult for me to manage the program, right? This is one of the reasons. So what we have listed here is just few drawbacks, what we can think about C programming language that helps me to go and write another programming language, okay, which allows me to manage my code, which allows me to reuse my code, which allows me to make my code flexible and allows me to extend and extensible. What I also mean is, in C, I can only think in reusability in terms of one method calling another method. So reusability can be spoken in terms of method calling. Method calling. But nowhere reusability will be there where I have something called a parent class, and that parent, I derive a child class from that. There is no way where I can have a relationship. So to overcome all these drawbacks which are associated with C, object-oriented programming language, okay, like C++, Java, they allow me to overcome these drawbacks. And when I overcome these drawbacks, what they basically help me to do is, they help me to provide these features. I can manage my program. That means I can maintain the size of the program. I can reuse the programs not just by method calling, but also in real life with inheritance. I can make my program flexible as well as extensible. So when I talk about object-oriented programming language, we have two things. One, either you can use C++ or you can use Java. But when I use C++, the concepts are based on object-oriented programming language. So since we are learning about Java programming language, we can understand that there is nothing new that I learn in Java in terms of syntax and all, because C gives me that style of creating the syntax. But when I use Java or C++, okay, here since we are talking about Java, Java gives me a semantic support. And when I talk about semantics, this is what it allows me to do. Since I could not write any of these support which is provided to me, the semantics allows me to manage my program, to reuse my program, to make my program flexible and extensible. So Java is derived, gets its syntax from C, but it has its own style of managing the program. That is what we call through object-oriented programming concepts. Okay. These concepts are also known as, so to build these object-oriented programming concepts, we say to support this object-oriented programming, there are 4 pillars. So this is what I can say. There are 4 pillars. It's based on 4 pillars. And of the 4 pillars, you have one which is encapsulation. So I can say 1, abstraction, 2, encapsulation, 3, I have inheritance, 4, I have polymorphism. So object-oriented programming language allows me to manage my program so that even though when I write a big program, there will be less spaghetti code. I can reuse my program not only in terms of one method calling another method, but I can reuse my programs where in real life, as we see inheritance, that is where I can reuse. I can make my program flexible, add a module, remove a module, it will not do anything. And I can extend my program over a period of time. For all these OOPS concepts, what you need something as a basis is a class, okay, an object, and how these objects or classes can communicate with each other. That is, I have message communication. Between the objects, I have message communication. These are the 3 underlying concepts on which these OOPS pillars are based on. So when I have this, when I say a class, whether in C++ or whether in Java. I say a class is just a blueprint, or it is a template. Like I build the plan, before building the building, I design a plan. There is no reason that I should build a building based on a plan. I can build a building without a plan. But you can see, tomorrow when I want to lay another structure, when I want to put another floor on the building, it's very, very difficult for me to extend without having a plan, because I do not know where the wiring is, where the pipeline is, where the sewage is, where the water is. It's very, very difficult. But if I have a plan behind it, what I can do is I can just build structure upon structure and pull the wiring, pull the sewage pipes, pull the water controls, whatever it is. So it's very easy to extend my program, very easy to reuse, very easy to manage. So when I have a blueprint or a template, okay, it becomes a class. But classes is what not I work with, because they're just a plan. Having a plan of a car, I cannot drive the car and go. So classes are always logical. Classes are always logical. That is, they are virtual. I can only think about them. But when I have to work with some methods, with some think about some features, I talk about an object. So an object is something which is physical. And when I say, if we say we define an object, which we say it's an instance of a class. Okay? An object is known as an instance of a class. So when I talk about physical, it means that it occupies memory. But when I talk logical, it does not occupy memory. I can think only of the plan of a building, the plan of a car, the plan of a laptop. So what we have is, we say from one class you can get n objects. This is what we have. So if you take from one car, from one design of a car, I can get many cars, physical cars on the road. Okay? So from one car class design, I can get n physical cars on the road. So how do I think what can be a class? How I can classify something as a class? So when I say class, it becomes something like a noun. Okay? Where I can describe some features of the class. Okay? And there are some verbs which tells me, what the car is doing. So if I think about the car, okay, I can specify something about the methods of the car. Okay? So what do I think? If I look like this, I can say all these features. So in object-oriented programming, as in C, where they are only in one C file, I have several methods where each method is independent of the other. In a class, I bind them together. That's a single unit. There is a single entity where I describe some features of the car, okay, and I define some behavior of the car. Where I can describe some behaviors of the cars. So these features are known, I can, in the car, in a class, which is the car, I can store them together as, describe them as variables. For the behavior, I can specify something called methods. So if I think about the features, something which, so how do I describe a car? The minute object-oriented programming says, what you see is real world. Okay, so features are nothing but like the color of the car, okay, the model of the car, the number of seats in the car, number of seats in the car, okay, like this I can describe the features of the car. The behavior of the car then becomes whether I'm starting the car, whether I'm stopping the car, stop the car, start the car, accelerate the car, or whether I'm braking the car. Okay, these are all the behaviors. So all of this becomes encapsulated inside the class file. So unlike the C program, where everything is only in thinking in terms of methods, where I describe the variables inside the main, I do forward declaration, I call one method within the other method. This is where I get this features, and I can have another class to describe a person, because it's a person who drives the car. So when I describe the class called person, now you can observe the features of a person. So I can talk about the height of the person, the weight of the person, the gender of the person, okay, the color of the person. So there are certain features which tells me what is the variables, what are the features which are associated with the person, and I can describe them as variables. What are the methods which describe what the person can do? So I can say write, okay, read, I can do a write, I can do a read, I can do a an eat, I can walk, I can talk. There are so many things I can describe. So when I have two objects, so physically I have a class, so I can say all of us are persons. And how I can tell a car is a class? Because of the class design, which comes in the logical design, which is the class. And when I talk, I can allow two objects to communicate with each other. So here you can see the person and the car can communicate with each other. So how will I talk about this? I can say via the physical object only. Okay, via the physical object only, I can access the variables or the methods, the behavior of the class. So if I create the physical object called car, I use a dot notation to access the members of the car. Okay, that is either the methods or the variables. So via the car, I can open the car, I can close the car, I can brake the car, I can accelerate the car. So unlike I have two method calls, calling one method to other method, here I use a convention called object name dot method name or a variable name. This is what is the basis of any object-oriented programming language. Okay. Based on this object-oriented concepts, what we see is the four pillars. This allows me to manage my program in terms of giving the semantic structure to the program. So one of the object-oriented pillar is abstraction. And abstraction simple tells me it is information hiding. Information hiding. And when I have this information hiding, so if you see about this class called car, you can see unnecessary. I do not want the entire, the mechanics of the car to be known to each and every user. What the end user is interested in database, we call this as views. What I want is what the end user is interested in just driving the car and going. So I don't want to tell him where is that engine, how the wiring is done, what happens, how are you starting the car and all. What I give is information hiding just tells me hide the unnecessary features. Okay. When I hide the unnecessary features, that is, I close everything in the bonnet of the car. And when I hide the unnecessary features, then I should give some interface to the user. I should give some interface to the user. And the interface is like when I hide everything, then how does the user know how he has to drive the car and go? So I have to tell him this is the key start, this is the ignition, put a key in the slot and start on the car. Or if you press a button and you have the car which is getting started. So when I'm hiding the entire thing, I should give him some way he can access that feature of the car to start the car and go. So I give him an interface which is a button or a start key to allow the start to go. But how that happens when I press that key or when I press that button or I put that key in that ignition slot, how does the engine start the car? So there is something called as binding, okay, which is known as data binding, which is also known as encapsulation. And data binding helps me to bind the data, okay, with the interface. So I say the interface, I bind the interface, that is the method, to the data. So what happens when I press the start button of the car or when I put that ignition on, that there is some wire which should connect to the engine so that either which ways the engine gets started. If you see one powerful feature, what we are talking here is, we never allow the data to be accessed by everybody. But if you see in C programming language, this was the major drawback, inconsistency of data. Okay, this is a major drawback when I speak about, it's an inconsistency of data. So what I'm doing here with this inconsistency of data, I'm saying here there is no protection to the data. I only think about in terms of procedures, what to do. I'm never bothered about the data in C. But object-oriented programming tells me that when you have such data in the form of variables, you should always protect your variables so that you do not give anybody access to it. Because the minute an end user like you and me tries to fidget with the wirings of the car, we are doomed there. Because we might, connect one wire somewhere else, or we do not know the internals of the car, and we may try to, do something wrong which totally goes in a chaotic form. So the best thing is protect your data. That is the major thing what we talk about. So protection of that data is what is given in object-oriented programming. So beauty of object-oriented programming, unlike your procedural programming, says, I'm not bothered only what to do. For me, object-oriented programming says data is important. This is an oops. Data is important. All my methods that I'm going to write will be based on this data only. So the problem which says inconsistency of data is eliminated. If you can see in C, we always said that there is one file in which you just have methods. But object-oriented programming provides me a structure to my program, okay, where I can think about an encapsulation, okay, which is binding, where I bind the variables and methods. So there are very many other ways in which I describe this. So these two are the major features or the major pillars. So my view is always to protect the data, but if I hide my data, how am I going to give users, if something is private, if something is hidden, I cannot allow other users to access the data. So what we do is, the moment you hide the data, you have to give them some interface, some methods which they are known as, so that by using that interface I can manipulate the data. So these are the two powerful features which are the OOPS features. Then object-oriented pillar, one of the pillar also tells me reusability, a very powerful feature which is seen in inheritance. The entire API of Java is based on these four pillars only, where inheritance is one of the major pillars. Without inheritance, you cannot see the power of Java. So inheritance tries to build me. Object-oriented programming is real world everywhere. So the minute you should be, or I say objects everywhere. So how I behave in real world, how I talk in real world, the same thing I can depict in objects. So inheritance tries to build me something called as a parent-child relationship. So it says, if you have something which is defined for the parent, why do you want to unnecessarily rewrite that again to the child? So if I think here, suppose I have a vehicle and I have a car. Inheritance gives me this. How do I know a car is a vehicle and a car is not a person? Because I say there is something which comes from the parent. Okay? There is something which comes from the parent which tells me that the car is a vehicle and not a parent. So what we have is a feature of inheritance which gives me reusability. Inheritance also tells me something called as generalization and specialization. So it helps me form a hierarchy. So like how we have a family tree coming from our ancestors to tell me I belong to this family and not to somebody else, it's this idea only. So inheritance tells me the topmost, the root of the tree tells me that this car is coming from somewhere called vehicle. And a vehicle gives me a description of what a car looks like or what a vehicle looks like. Maybe it can be a four-wheeler, it has tires, it has a steering wheel, something like this, which helps me to identify, okay, car is a vehicle and not a person. So inheritance gives me something called as reusability. So once I describe a vehicle, I know I can get many cars out of it. And from car, I can then decide, what are the different categories that I'm looking for. So I can look something called a luxury car, okay, maybe like a BMW, or I can look like a sports car, or I can look like a normal, a daily use car, something like this, like economy car. There can be several other things. So what I'm doing is I'm building a hierarchy which helps me to go from generalizations to specializations. This is the power of all object-oriented programming language. And polymorphism addresses that feature of C where I cannot write two methods with the same name. So we have seen. So unnecessary, though the functionality is the same of A plus B, still I have to write different methods which takes different parameters. So which makes unnecessary my program difficult to remember the methods, difficult to manage. I have to write this. If you imagine your calculator, the calculator also implements the OOPS concepts. Because when I have on the calculator, I only have one button called plus. Whether I say 2.3 plus 5.0, it does me the value. Whether I say 400 plus 500, it gives me the value. So this is what object-oriented program simulates, polymorphism, okay, which is seen in two forms. One is known as overloading and overriding. Overloading and overriding. So both of them allows me to reuse my program, okay, in different ways. So here with overloading, what I do is I can write that same method but with different parameters, okay. Overriding comes with something called as inheritance, where I have, so when I talk about this similar concept, similar functionality, so when I have similar functionality, instead of writing dissimilar methods name, this feature, what I say is overloading. When I write the same method with different signatures. So polymorphism tells me that when you think there is a common functionality, okay, in the parent which is defined for the methods, it tells me you can give one interface, but behind that interface you can have n methods. This type, okay, that means you have, so if you think in real world, if you think, we all depict polymorphism somewhere. So if I talk about me, I can think that I am a trainer, I am a mother, I am a wife, I am a daughter, I am a friend. There are so many forms to me. So I'm a single person which has different functionality, and whichever form I invoke, that functionality takes precedence. So polymorphism allows me to do that. Through overloading, it allows me to do this. Whenever I have the same functionality, which is add, I can implement it in one way where I can have the same methods but different signature. Or in overriding, what I can do is, overriding comes with inheritance only. Only if there is inheritance, then I have overriding. Okay? And overriding brings that power of inheritance. So it tells me what the parent is defined. The child can inherit the same thing, but the child can override the behavior. Okay, a very basic example to understand the concept. Say if the child is a singer, then, the parent is a singer, then the child will definitely be a singer due to inheritance. But maybe if the parent is singing, say, some classical, the child will definitely inherit that classical behavior. But what the child can do is, the child can override that behavior. And when I say override the behavior, the child can sing, say, pop. So inheritance allows me to get that functionality from parent. But overriding, which is also a type of polymorphism seen in inheritance, allows me to override that behavior. So I'll have two methods which are the same name. So they're always spoken in parent-child. So I'll have a method, imagine, I have a method, like, say, void sing in the parent. Okay, where I say something like this, where I say something like singing classical. But the same thing in the child, the signature would be absolutely the same. But instead of singing classical, he will inherit classical, but he can sing pop. So if you look at this, overloading can be done in a single class, where such a form of overloading will have same methods, but the signature are different. But in overriding, the signature in the parent and the child is absolutely the same. Absolutely the same. But what changes is the logic. So in overloading, you have change of signature, but here you have, in the parent, you have something called as, in overriding, you have change So I have change of signature. Here I have change of logic. Change of logic. Signature remains the same. Okay. So I think with this concept you should be able to understand and appreciate the differences of C as a programming language and why object-oriented programming languages, whether C++ or Java, will be helpful to us. Okay. So once we get started, we will be able to explore about, since we are learning in Java, object-oriented programming is in Java, we will see how object-oriented programming works and how I can use object-oriented, how I can understand object-oriented programming to help me understand the power of Java, that is the API. Okay.